Today we're looking at piecewise functions 1.2 in our note guide. A piecewise function is formed when you take multiple pieces of different graphs and kind of put them together. So this first example, it has our f of x is equal to x minus 2 if x is greater than 0. And it has 2x minus 1 if x is greater than 0. So the expression represents x minus 2 when x is less than or equal to 0. So if I look less than 0, I get all of this piece here. And when x is greater than 0, I'm getting this piece up here. So it's kind of put into two different groups. Okay, we're going to start by looking at this story problem. So there's some water in a reservoir. And then in the springtime, when the snow is starting to melt, the reservoir gets higher, okay? So the water is melting. And then it has a period of time where it just stays constant and not a lot of water. It's just kind of at an equilibrium point. And then at a period of time, it decreases. So there's three different lines in this graph. So it's a piecewise function. It's got three different pieces of different graphs. So we're going to model this as a relationship, okay? So the first part of the graph, the pink, represents the first 15 days of the month. So we want to take the coordinate points at the beginning and end of this part of the graph. So that pink one, it's starting here at the point 0, 10. And it's going up until day 15. On the 15th day, it hits a peak of 25 feet. So it started at 10 and ended at 25. So we're going to write a linear equation to represent the level of water during the first 15 days. Well, we know how to find this. We just take the slope. We have y2 minus y1 over x2 minus x1. Our y2, let's label that as x1, y1, x2, y2. And if we're taking y2 minus y1, we're going to have 25 minus our y1 is 10 on top. On the bottom, we have 15 is our x2 minus 0 is our x1. So the slope of this equation is 25 minus 10 is 15, and 15 minus 0 is also 15. And 15 divided by 15 is 1. So our slope is 1. So we have, we can take, from this point, we can look on our graph to find our y-intercept. Our y-intercept on this graph is 10. So it's crossing at 10. So I have y equals mx plus b. Y equals, my slope is 1. Have an x plus my beginning spot is that 10 right here, and we are going to add 10. Now, if I can simplify this just a little bit more, I can say y equals x plus 10. So that's the equation of my first line. So the second part of the graph represents days when the water level remained constant. So the points at the beginning and the end of this part of the graph are represented with this point here and this point here. So we're going from 15 over 15 up 25. 15, 25. And we go all the way until we hit day 20. And we have 20, 25. So here, my slope is if I take y2 minus y1 over x2 minus x1, both of my y values are 25, and 25 minus 25 gives me 0. 20 minus 15 is 5. 0 divided by 5 is 0. So this has a slope of 0. Now, whenever you have a slope of 0, you have no x's. So you're going to need just y equals a number. So we want to look at the y here. Since the y is 25 here and 25 here, the equation of this line is just y equals 25. Because y is equaling 25 on that whole line of that equation. That whole piece is at y equals 25. It's constantly y equals 25, no matter what number you have. So that's what we would put on D. Y equals 25 for the equation of that line. So the third part of the graph shows a drop in the water level due to irrigation. So we want to look at the points at the beginning and the end of this part of the graph. So we're starting at the point over 20 up 25, and then we're decreasing. At day 30, we're back down to 20 feet, okay? So if you look right here, this is the point 30, 20. This is the point 20, 25. So 20, 25, and 30, 20. So I want to find the slope between these 2 points. So I have my equation, y2 minus y1 over x2 minus x1. I need to label these points, x1, y1, x2, y2. So I'm going to take 20 minus 25 over 30 minus 20. This gives me a negative 5 on top and a 10 on the bottom. Now, negative 5 over 10 reduces to negative 1 over 2. So this is our slope of our equation. Now, I can't really easily tell where, if I were to extend this line out, where it would cross the y-axis, okay? So I've just got to create the equation of a line. So we have the equation y minus y1 equals m times x minus x1. So what we're wanting to do is we want to take y minus our y1. In this case, our y1 is 25, equals our m, which is negative 1/2, and x minus our x1, which is 20. Now you could use the x2 and y2 in your equation. Either one of those points work, but we're just going to use that x1, y1 since we've already labeled it. So I'm going to distribute that negative 1/2 through. I'm going to put it into each of these pieces. So I have negative 1/2 x. And if I take a negative 1/2 times the negative 20, and negative times a negative is a positive, and half of 20 gives me 10. We're going to add 25 to both sides. And I get y equals negative 1/2 x plus 35. Okay, so we're going to combine, so that's what our F equation is, y equals negative 1/2 x plus 35. Now I want to just write my 3 equations on these lines. My first equation was y equals x plus 10. This L of D is representing the y. So it's just a fancy way of saying y. In my first equation, I'm going to add x plus 10. My second equation was y equals 25. We've already got the y here, so we're just going to write 25 in the second line. And the third line is negative 1/2 x plus 35. we want to find our D. D is how many days. So from day 0 to 15, it was the equation x plus 10. And then if we're looking at the graph between days 15 and 20, we are constant at 25. So in between days 15 and 20, it stays the same. And then between days 20 and 30 here, it started decreasing. So when the days were between 20 and 30, we have a negative slope here. Now we're going to use this is how we define that function. We're going to take that and we're going to find L of 5. What L of 5 means is everywhere we're going to take into our L, we're going to plug a 5 in. So this is asking on day 5, how deep was the water? Okay, so on day 5 is in between 0 and 15. So we're going to use that first equation, x plus 10, to figure out how deep the water was. So on day 5, I'm going to put a 5 plus 10 is equal to 15. So on day 5, it's 15 feet deep. So let's look at that graph just to make sure that that is correct, okay? So if I were to look at day 5, it's going to be right at 15 feet right here. So we're looking at that point right there on our graph. If on day 16, how deep is the water? 16 is in between 15 and 20. And anytime it was in between 15 and 20 days, the depth stays constant at 25 feet. So this is equal to 25 feet. On day 27, that is in between 20 and 30 days. We're going to use the equation negative 1/2 x plus 35. So I'm going to take negative 1/2 times it by 27 and add 35. So this is negative 27 over 2 plus 35. Take 27 and cut it in half. That is negative 13.5. So we're going to take negative 13.5 and add 35 to that. So that's the same as saying 35 minus 13.5. Or at 27 days, it's going to be at 21.5 feet. So let's just look at this graph. At 27 days, that would be right here. It's going to be right in between the 21 and the 22 mark on our graph. Okay, and then at 20 days, we are going to plug it in. But since it's equal to 20, and this one's so easy, let's just say it's at 25 feet. So on day 20, we're going to be right here at the 25 feet mark. So the next one, we're going to follow the steps to write a piecewise equation for the given graph. Okay, part A. What are the coordinates for the beginning and end of the first part? We have this point here. This is the point -5, -6. And we'll write it here. Our second point is this point here at -1, 2. So we're going to write an equation for this piece of the graph. First, we're going to find the slope. y2 minus y1 over x2 minus x1. Let's label the points, x1, y1, x2, y2. We take 2 minus our y1, which is -6. 2 negatives make a positive. On the bottom, we have x2, which is -1, minus our x1, which is negative 5. 2 negatives make a positive. 6 plus 2 is 8. Negative 1 plus 5 is the same thing as 5 minus 1, which is 4. 8 divided by 4 is 2. So our slope is 2. Now we're going to take our y minus y1 equals m times x minus x1. So we take y minus our y1. Our y1 is a negative 6. So if we have y minus a negative 6, that's the same as plus 6. Our m is 2. And we multiply that by our x minus our x1. Our x1 is a negative 5. 2 negatives make a positive. And so I have y plus 6. I'm going to distribute this 2 through. And I have 2x plus 10. I'm going to minus 6 from both sides of my equation, and I end up with a piece of the graph of y equals 2x plus 4. So that would be the equation here. Okay, now if you look right here, it's going up 2 over 1. That's where I get my slope here. And if I went up 2 over 1 here, it would intersect the y-axis at 4. So that's why it's going to be 2x plus 4. Now we're going to find the coordinates for the beginning and the end of the second part of the graph. Right here, I have the point negative 1, 2. And right here, I have the point 7, 2. Now, since both of the y's are 2 and it's a horizontal line, this is going to be the equation y equals 2. Now, my slope, if I were to subtract 2 minus 2 on top and 7 minus a negative 1 is 7 plus 1, that's 0 over 8, and that gives me the slope of 0. So this is really like y equals 0x plus our b, where it's intersecting the y-axis is going to be 2. That's why we get the y equals 2 there. Now we're going to, let's look at this and we're going to combine these equations. The first equation is f of x, just is another way of saying y. Y equals 2x plus 4. And our second equation is y equals 2. Now, we are going to, we want to see what is the x in between. Here, the x is at negative 5. Here, the x is at negative 1. So we're going from negative 5 to negative 1. Now, this piece, it's starting at negative 1, and it's ending at 7. So it's in between negative 1 and 7 there. Okay, so now we're going to evaluate the function. We're going to find when x is negative 4, what is y? So we're going to take negative 4 and we're going to plug it into this equation here, because negative 4 is in between negative 5 and negative 1. So we're going to take 2x plus 4, and in everywhere there's an x, we're going to put in negative 4. 2 times negative 4 plus 4. This equals negative 8. 2 times negative 4 is negative 8, plus 4 is equal to negative 4. Okay, so f of negative 4 equals negative 4. Now we're going to take f of negative 1. Negative 1 is at the end point, okay? So we want to find which one it's equal to. Since there's a less than or equal to sign right here, we want to plug it in this one. If it's equal to 1, it's going to be here. On this one, it has a less than equation, so we're just going to put it into the endpoints. So we're going to have 2 times negative 1 plus 4. We're taking the same equation here, I'm putting a -1 in everywhere there's an x. So we have -2 plus 4 is equal to 2. Okay, so f of -1 equals 2. Now, if we have a 3, f of 3, we're going to plug it into the second equation. The reason is that 3 is in between -1 and 7. So anytime the x is in between -1 and 7, the y is going to equal 2. We get this number here is this number here. Okay, now we're going to write a formula for the piecewise function. So we have the equation y equals mx plus b. We want to find the slope of the line. The slope, we can find 2 points. We have up to over 1. Up to over 1. Now, if I kept going here, I would end up with this point here and this point here. It's going to intercept at 10, even though it doesn't quite get there. So we have y equals 2x plus 10, and that's going to be the equation of this first line. Now let's look what the x's are. It's going to be y equals 2x plus 10 if x is in between this point right here at -9 and this point right here at -2. For the second piece, we're looking at this equation right here. We want to start, we have our equation y equals mx plus b. We're beginning at 4, and we go up 1 over 2, 1/2 x plus 4. Okay, so this is in between -2. The x is in between -2 and +6. We have that 1/2 x plus 4. Our last piece of the equation is here. Okay, so we have y equals mx plus b. My slope is going down 1 over 1, down 1 over 1, down 1 over 1. So I have a -1x. Now, if I were to extend this up here, it would intercept at 7. So I have y equals -x plus 7. Now I want to show you a different way that I can do that. I have this point here, it's the point 6,1. I have my equation y minus y1 equals m times x minus x1. That gives me that same equation I got here, y equals -x plus 7. Now this one is if x is greater than or equal to 6. So this is the 6. So if it's greater than or equal to 6, we get this equation here. So graphing the piecewise function. Okay, so first thing is we're going to draw boundary lines at 3 and 7. Okay, so we're going to put these dotted lines here and here. Now the first piece of the function is a horizontal line. It is at 5. If x is less than or equal to 3, we have the equation 5. So we're going to have this line here. The second piece of the equation is a slanted line. It looks like we start at 3 and go down 2 over 3, down 2 over 3. And we get this line. So then we're gonna erase any part of the lines that are not within the boundary. Okay, so I'm gonna take this and erase. So I only have this piece. The only part of this graph is gonna be here. And when it's less than or equal to 3, we get this graph here. And so when we're done, we have this piece and this piece here. So first we're going to identify and mark the boundary. Then we're going to identify and indicate the type of function. Then we're going to draw each piece of the function. Okay? Okay, so we are going to graph these. So first step is we're going to identify and mark the boundary. The boundaries are 2 and 6. So I'm just going to kind of draw a dotted line here at 2 and a dotted line here at 6. Then we're going to indicate the type of function. These are lines. We're going to draw each piece of the function next. Okay, so I can draw each piece of the function. So piece number 1, I'm going to do in green. It's at -4, and it's going to be -4 everywhere. The second piece of the function, I'm going to have be purple. I'm going to start at -3, and I go down 1 over 2, down 1 over 2, down 1 over 2. Okay, now we're going to erase any pieces that are not part of the function. Okay, so I'm going to, the -4 graph, or y equals -4, is only when x is less than or equal to 2. So I'm going to erase all of this over here because that's bigger than 2. I don't want that part of the graph. And then on the second graph, the orange here, it's the purple line graph. I only want it in between 2 and 6. So I'm going to erase all the pieces that aren't in between 2 and 6. Now we're going to draw the correct symbols at the end of each piece of the graph. If you have a less than or equal sign, you're going to do a closed circle, or a greater than or equal sign is a closed circle. If you have a less than or a greater than, you're going to put an open circle at the end of the piece. So since x is less than or equal to 2, we're going to draw a closed circle right at the end of the piece. If x is less than 2 and in between 2 and 6, right here, it's an open circle. But since it overlaps with a closed circle, we can just kind of have it be a closed circle there. Then we have our graph line here. This right here is a less than or equal sign, so we're going to have a closed circle there as well. Okay, now this is asking us find the value of x. If x is -5, what is y? So we're looking at -5 here. -5 is right here. The y is going to be right here at -4. Another way you can look at it is from the equations. Since -5 is less than -2, we're going to use this equation here. So it has, this is a -4. Our second piece says, what is the value of y when x is 4? So since 4 it's in between 2 and 6, so we're going to use the -1/2 x minus 3. And in for the x, we're going to put the 4. So we have -1/2, we're going to plug a 4 in here, and minus 3. We have a negative out front. Half of 4 is 2 minus 3 is equal to -5. So when x is 4, y is going to be right here at -5. We have that point right there. That's the point for -5. So when this 4 corresponds here, this -5 corresponds to this. Our last example has 3 equations. The first one is 5 when x is less than or equal to -5. Our second one is 1/2 x minus 1 if we're in between -5 and 2. And our third one is 2x minus 2 if x is greater than or equal to 3. So first, our first step is we want to identify and mark the boundaries. Okay, so our boundaries are at -5 and 2. And then we also have a 3. So our first equation is y equals 5. So y equals 5 looks like this. But we only want that equation if x is less than or equal to -5. So what I'm going to do is I'm going to take the eraser and I'm going to erase everything on the right side. In between -5 and 2, I'm going to use the equation 1/2 x minus 1. So I want to begin at -1. I want to go up 1 over 2. Now 1 over 2 is equal to -1 over -2. So I can also go down 1, left 2. And I'm doing this more because I'm trying to go between -5 and 2. So I only need this to be from between these 2 points here. Now, if you look right on, let's see. Okay. On the third line, the orange, I have, if x is greater than 3, I have the line 2x minus 2. So I'm going to start at minus 2. And then 2x gives me, it's a up 2 over 1. So we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so I've got this line here, but I only want it when x is greater than or equal to 3. So I'm going to erase everything on here except for when it's greater than 3. Okay, so then our last piece is we want to draw the correct symbols at the end of each piece of our graph. So I have a less than or equal to sign here. So I'm going to put a solid dot on that yellow piece. On the green line, let me make that a little better because I had to erase over it. On the left side, I have a less than sign. It's not equal to. So what I'm going to do is I'm just going to erase a little more on that. It's going to be an open circle right there. On the right-hand side, at 2, it's an equal sign there. So it's going to be a closed circle. And our last equation is if x is greater than or equal to 3. So x is 3 here. So we have a closed circle right there, and then it continues on. Notice there's an area where there's no graph in between 2 and 3, okay? So it's not defined there. So at f of -6, I can do it on the graph if I want, or I can use the equations. F of -6 is here, and it is at 5. So since -6 is less than -5, we're using this equation, and the y is going to equal 5. Or we can look at it on the graph right here, y is equal to 5. When x is 5, 5 is greater than 3. So we're going to use the third equation. We have 2x minus 2, which if we plug in a 5, we have 2 times 5 minus 2 is 10 minus 2, which equals 8. So at 5, we have 8. So it's going to be clear up here. This is our point. When x is 5, right here, y comes up to be 8. F of 0, if we look on the graph, it's right here at -1, or 0 is in between -5 and 2, so we use the second equation, 1/2 times 0 minus 1. 1/2 of 0 is 0, minus 1 is -1. Now, f of -2, or f of 2.5, is in this no graph area right here where nothing is here. So this is actually going to be undefined. It hasn't been defined at 2.5. -4 is in between -5 and 2. So we're going to use that second graph, 1/2 x minus 1, and we put the -4 in for x, which equals 1/2 times -4 minus 1. This is -2 minus 1, which is equal to -3. Okay,